Hi students, let us look at these problems based on this property for definite integrals. Okay, let us look at the first question. First question is I equal to integral from 0 to 1 x into 1 minus x raised to n dx. Here the property applied would be the property number 4, which says that 0 to a fx dx is equal to integral from 0 to a f of a minus x. Okay, so here what we are given is I is equal to 0 to 1 x into 1 minus x the whole raised to n into dx. Okay, so we shall be writing this as I equal to apply this property. We shall apply this property, and what we get here is 0 to 1 x can be replaced by a minus x. Okay, that is here a is equal to 1, so it is 1 minus x. X will be replaced by 1 minus x into here this becomes 1 minus of 1 minus x the whole raised to n into dx. Okay, so this further simplifies as integral from 0 to 1 1 minus x into 1 minus x into x raised to n into dx. So this can be multiplied inside to get something like this. Integral from 0 to 1, this x raised to n can be multiplied, and what we get here is x raised to n minus x raised to n plus 1, which can be easily integrated. Okay, this can be integrated easily. So integral of x raised to n or separately. Okay, integral of x raised to n is x raised to n plus 1 divided by n plus 1, and integral of x raised to n plus 1 will be x raised to n plus 2 divided by n plus 2. Okay, and the limits of integration shall be placed here. Okay, now we shall apply the limits. So when we apply the limits, we shall first put f of 1 and then put f of 0, x equal to 0. When we put x equal to 1, we get 1 raised to something divided by this. So it is 1 by n plus 1 minus here again 1 by n plus 2. Okay, and when we put 0, the items become 0. So while simplifying, we can further simplify this thing to taking LCM n plus 2 minus of n plus 1. The numerator divided by n plus 1 into n plus 2, which simplifies out to 1 by n plus 1 into n plus 2. So the problem is very simple. We just apply this property to get this step. Okay, so that's it for this problem. We shall move on to the next question using the same property, f of x. Okay, question number 2. So here also we shall be taking I will be given, will replace x by a minus x. Okay, we shall replace x by a minus x. So it is 0 to a, so we shall replace x by a minus x, and let us see what happens. It will be equal to the same integral, 0 to a, x will be replaced by a minus x. So a minus x, this is your first equation. Okay, a minus x divided by root of again a minus x plus root of x. This can be considered as the second equation. When you add these two i's or these two equations, adding these two equations, we get 2i. Okay, what are we doing? We are adding equation 1 and equation 2. We get 2i equal to integral from 0 to a root of x plus root of a minus x divided by root of x plus root of a minus x. Okay, this will be there inside. We can add this part and this part. Numerators can be added as the denominators are the same. Okay, into dx. Okay, so this becomes equal to integral of 0 to a 1 dx, which comes out to be, okay, this is 2i will be equal to integral of this. So that is x. Integral of 1 is x. We put the limits from 0 to a. So what we get here is a minus 0. So that is equal to a. So I will be equal to a by 2. In this case, I is equal to integral of this expression is I is equal to a by 2. Now let us look at the third question. So here what we have again of the same type. The problem is of the same type. I is equal to integral from 0 to a f of x dx. Okay. Now here what are we going to do? Here we are going to replace x by pi by 4 minus x. So what happens? I will become equal to integral from 0 to pi by 4, and this is log of, look at this problem, 1 plus tan x becomes tan of pi by 4 minus x, okay, into dx. Okay, so tan pi by 4 minus x, or tan of a minus b, we know the formula, and it can be further simplified as 0 to pi by 4 into log of, this is 1 plus tan pi by 4 minus x can be written as tan pi by 4 minus tan x divided by tan pi 1 plus tan pi by 4 into tan x. Tan pi by 4 will give you value 1. Okay, so we can directly write down as 1 minus tan x divided by 1 plus tan pi by 4, which is 1, into tan x. Okay, tan x into dx. Further, integral from 0 to pi by 4 into log of taking LCM, what we get is 1 plus tan x plus 1 minus tan x. So it is 2, tan x will get cancelled, and then we get 2 by 1 plus tan x into dx. Okay, so this is what we get. So this can be written down as, so this is the first equation, this is the second equation. Okay, now comparing or adding these two, what do we get? Adding 1 and 2. Okay, adding equation 1 and equation 2, we get I or 2i. Okay, 2i will be equal to, look here, okay, here what we get is this is the first one, and then this is the second one. The second one can be written as log 2 minus log of 1 plus tan x. So the first equation, integral from 0 to pi by 4, the first part will be log of 1 plus tan x, and from the second part, log of a by b. Log of a by b is equal to log of a minus log of b. So I can write it as plus log of 2 minus log of 1 plus tan x into dx. Okay, so this dx. Further, here we can see that these two items can get cancelled. Log of 1 plus tan x and log of this will get cancelled. Then let's come back. So this is 2i will be equal to integral from 0 to pi by 4. It is log 2 into dx. Log 2 is a constant, so 2i will be equal to log 2 into x with the limits 0 to pi by 4. Okay, so when we put the limits, we get log of 2 into pi by 4 minus 0. Okay, so that is equal to log 2 into pi by 4. So when we take this to I, okay, I will be equal to pi by 8 into log of 2. This will be our answer. Okay, is that clear? Let's look at the problem again. Okay, next question. Again, this problem is also of the same type. Okay, so let us see here. We need to eliminate this x. Okay, so for that purpose, we shall apply this property, integral from 0 to a fx dx is equal to integral from 0 to a f of a minus x into dx. Okay, this is the special case of King's rule. This formula is a special case of King's rule. Okay, So this is 0 to pi by 2. Okay, so integral from 0 to pi by 2 into x will be replaced by pi by 2 minus x. So this what we get here is pi by 2 minus x into sine of pi by 2 minus x into cos of pi by 2 minus x. Okay, whole divided by sine square or sine raised to 4 of pi by 2 minus x plus cos raised to 4 of pi by 2 minus x. Okay, sine pi by 2 minus x and cos pi by 2 minus x remain the same. Okay, so means we can just sine pi by 2 minus x is sine x and cos pi by 2 minus x is sine pi by 2 minus x is cos x and cos pi by 2 minus x is sine x. Okay, so this becomes integral from 0 to pi by 2. This is pi by 2 minus x into this item. What is this? This item is cos x into sine x, that is sine x into cos x. The first one is cos x, the second one is sine x, divided by this is cos raised to 4 of x and this is sine raised to 4 of x, but I am writing it like in the order as it was. Okay, so that is sine raised to 4 of x plus cos raised to 4 of x into dx. I did not place a dx here. So now adding these two, this is the first equation and we shall take this as the second equation. So adding these two, what we get is 2i. Okay, 2i will be equal to, see, x and x will get cancelled, remaining everything is a common part. Okay, so what I get is pi by 2 into integral from 0 to pi by 2 and that again will be constant, so it is pi by 2 into sine of x into cos of x divided by sine raised to 4x plus cos raised to 4x into dx. When we come across this kind of problem where we have sine raised to 4x plus cos raised to 4x in the denominator, we divide the numerator and denominator by cos raised to 4x, so that we can get tan in the denominator and sec square in the numerator. Divide the numerator and denominator by cos raised to 4x. We shall divide the numerator and denominator by cos raised to 4x. So dividing numerator and denominator by cos raised to 4x, we get as pi by 2 as it is 0 to pi by 2. See, sin x into cos x divided by cos raised to 4x will become, see, this is sin x into cos of x divided by cos raised to 4x. So one cos will get cancelled, sin x by cos x will be tan x into sec square x. Okay, so we get, what we get here is, see, tan x into sec square x. Okay, so this is tan x, okay, tan x into sec square x divided by 1 plus tan x, tan x or tan raised to 4x plus 1. Okay, so that is, I am writing it as 1 plus tan raised to 4x. Tan raised to 4x can be written as tan square x the whole square into dx. Okay, here I will be taking tan x is equal to t. Okay, now we shall take tan x is equal to t. Okay, so let tan of x equal to t. So what we get is what we get, I'll take tan square x is equal to t. So we get 2 tan x into sec square x dx equal to dt. Okay, so we don't have a 2, so we can multiply and divide. Or we can take it as 1 by 2 on the other side. So finally we have, this is pi by 4 into integral of, because we have multiplied and divided by 2, so 2 will appear here and 2 will appear here. Okay, so tan x into sec square x So tan x into sec square x dx is equal to dt by 2. So that 2 is here. So it is dt divided by, the limits are 0 to pi by 2. So I did not change the limits. So we always should change the limit as soon as we shall do it later. So it is 1 plus t square into dt. Okay, dt is already written. Now the limits, as x tends to 0, as x tends to 0, what happens to t? As x tends to 0, t tends to 0. As x tends to 0, t tends to 0. And as x tends to pi by 2, t tends to infinity. So we have 0 to infinity 1 by 1 plus t square into dt. Okay, so this is 1 pi by 4 into integral of 1 plus t square is tan inverse t. We shall put the limits from 0 to infinity, which will give you, this is pi by 4 into, say, tan inverse infinity minus tan inverse of 0. So this will be pi by 4 into, what is tan inverse infinity? Tan becomes infinity, tan inverse tan becomes infinity at pi by 2. So it is pi by 2 and tan becomes 0 at 0. Okay, so again minus of 0. So it is pi square by 8. Okay, so what we have here is 2i, this is 2i, this is 2i, this is 2i. 2i is equal to, this is pi square by 8. This is equal to pi square by 8. Okay, 2i is equal to pi square by 8. So now I shall be equal to pi square by 16, and that is your correct answer. Okay, we shall now move on to the next question, which is further very simple as we did in the first case or the second case. Okay, so here again we shall be taking cos of pi minus x. What is cos of pi minus x? Instead of x will be replaced by pi minus x. That is what we do. X will be replaced by pi minus x. So I will be equal to integral from 0 to pi e raised to cos of pi minus x divided by e raised to cos of pi minus x. X was replaced by pi minus x. Okay, then the integral does not change. The value of the integral does not change. That is what the property says. So it is e raised to minus of cos of pi minus x into dx. Now we know that cos of pi minus x, so it is the second quadrant, right? Cos pi minus x, second quadrant, cos is negative, so minus of cos of x. So we shall replace this again, integral from 0 to pi. What is this? E raised to minus cos x divided by e raised to minus cos x plus e raised to cos x into dx. This is the first one, this is the second one. When you add both of them, the numerators will get cancelled and we will get 1 as the integrand. So I plus I, adding 1 and 2, adding 1 and the second equation, we get 2i equal to integral from 0 to pi. Okay, the numerators will be, the numerator and the denominator will become same. So what we have, integral of 1 dx, and which will be equal to x 0 to pi, that is equal to pi minus 0, which is equal to pi. So I will be finally equal to, say 2i is equal to pi, so I is equal to pi by 2. Fine. Now let us move on to the next question. Here in this question, we shall apply the properties of log to simplify this expression first of all. So that is equal to integral from 0 to pi by 2. So this is your I, which can be written as c log of sine x the whole square. So that is sine square x. Sine square becomes a log of, so the numerator becomes sine square x. And the denominator can be taken as sine 2x, which can be written as 2 sine x into cos x. And one sine can be cancelled. So one sine can be cancelled. So we get this as equal to integral from 0 to pi by 2, 0 to pi by 2 log of, see, sin x by cos x is tan x, so it is tan x divided by 2 into dx. Now we shall apply this property of changing x or replacing x by pi by 2 minus x. So what we have here is log of tan pi by 2 minus x divided by 2 into dx. And what is that? That is again 0 to pi by 2. Tan pi by 2 minus x is cot x. Okay, cot of x by 2 into dx. We shall take this as the first equation and this as the second equation. And when we add both of them, so we get 2i. Adding both of them, we get 2i is equal to integral from 0 to pi by 2 log of a plus log of b equal to log of a into b. So I shall multiply them directly. So we get tan x by 2 into cot x by 2. So it becomes by 4. Okay, into dx. Okay, now tan x into cot x is 1. So this becomes equal to integral from 0 to pi by 2 log of 1 by 2. So 1 by 4 dx. So that is 2i will be equal to log of 1 by 4 into x. Okay, integral of 1 dx is x, 0 to pi by 2, which is equal to, see, pi by 2, x is, instead of x we put pi by 2, so it is pi by 2 into log of 1 by 4. Log of 1 by 4 can be written as log of 1 by 2 the whole square, that, and 2 can be written in front, so we get 2 into log of 1 by 2. You can cancel this, and then I will be equal to, and this implies that I will be equal to, see, 2i is equal to pi log 1 by 2, so it is pi by 2 into log of 1 by 2. Very important question and very simple too. Okay, so that's all for this class. If you like this video, do subscribe and share it with others. Thank you.